So today we're going to talk about similarity. The first thing we need to know is the definition of similarity. Similarity is something that is the same shape, so circles, squares, rectangles, quadrilaterals, triangles, whatever, the same shape, but the sizes are different. So we could draw an equilateral triangle is a really good one to think about. I can draw an itty-bitty equilateral triangle. All the sides are the same. All the angles in an equilateral are 60 degrees. So there's my tiny itty-bitty equilateral triangle. And then I can draw another equilateral triangle that is bigger. Now all these angles are still 60 degrees. And all its angles or sides are equal to each other, but they're not equal to the first triangle that I drew. So these would be similar. We use this little tilde for a similarity symbol. So it's like congruent, but it doesn't have the equal sign because congruent means same size and same shape. This is just same shape, different size. So generally speaking, that's the definition of similarity. Similarity in polygons occurs when all the angles are congruent and the ratio of the measures of the corresponding sides are equal. So all of the angles are the exact same measure, all angles are congruent, and the ratio of the measures of corresponding sides are equal. That essentially means that the sides are proportional. We talked about that in our last class about ratios that are equal are proportional. So you could have sides that are 1 to 2. So maybe this is 1 and this is 2. So then all of the sides would be 1 to 2. The second triangle is twice as big as the first triangle. We're going to do two postulates in this. Our first postulate is going to be angle, angle, angle similarity. And it's kind of what we just talked about with those triangles, those equilateral triangles. If you have two triangles where all three angles are congruent to each other, then the triangles are similar. We don't need to know anything about their sides. As long as we have three congruent angles, we know that the two triangles are similar. So here we have two right triangles that are actually isosceles right triangles because the other two angles are both 45 degrees. But these two triangles are similar because all three of their angles are congruent. So we have one pair, then we have a second pair, and then we have a third pair. So as long as all three of the angles are congruent, then the two triangles would be similar. Okay, the other similarity that we're going to use today or talk about in this video is angle-angle similarity. And it's kind of like, well, duh, if we have two angles in one triangle congruent to two angles in another triangle, the triangles are similar. Well, if we have two angles congruent in one triangle to two angles in another, the third angles are automatically congruent, taking us back to the last postulate that we talked about. So really, we don't need that postulate ever because we can use angle-angle similarity. So as long as we have two angles, we don't need all three, we can have enough information. So here's kind of what I mean. Okay, so let's say we have these two triangles, ABC and DEF. So let's say the two triangles have two pairs of congruent angles. So we've got that angle A is 40 and angle D is 40. So those are congruent. Angle B is 60 and angle E is 60. So those are congruent. Well, you already know what the third angle is, you all. We know that together this is 100 degrees. So that means that angle C could be determined as 80 degrees. So that means that this would actually be angle-angle-angle similarity if we wanted it to. But we don't need to go through all that work. This theorem says you don't need all that. As long as you have two angles, we have enough information. So since we have the two angles, 40, 60, 40, 60, the two triangles can be similar just by that information alone. And the way we would list that is we would say triangle ABC is similar to triangle DEF. We still want those angles to line up, just like we've done in the past. So we still want angle A to go with angle D. We still want angle B to go with angle E. And we still, then C would be the remaining angle and F would be the remaining angles that we don't necessarily need, but we have them if we need them. So there you go. Angle, angle, similarity, and angle, 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 which you'll never use. You'll always go with this guy, angle, angle, similarity.